First of all, good afternoon to everybody. And I will start with a small promise to Ronn. He raised an issue a minute ago talking to Zev, and I promise you that in my last slide, you'll get an answer for it, okay? So now you have to wait and be patient till the last slide. And I will begin with asking you if you are familiar with the 3 phases of autonomous driving. Of course not, because Zev is looking at me right now and he says, what the guy is talking about? First of all, I know, Zev knows about 5 or 6, okay, not 3, and he said it's automatic driving, not autonomous. So what is Israel talking about? And actually the story is very simple. I have a partner who works with me, and this partner is a German guy from the automotive industry, and his version for autonomous driving is the following. First of all, today, when you want to get to your office, for instance, you get into the car, you start the car, and then the car, you are driving the car to your office or to any destination you want to get, okay? Now, the next phase, guys, tomorrow, or within 5 years, is going to be that you will get to your car, and the car will ask you, where do you want to go? And then you'll say to the office, and then the car takes you to the office. Now come the 3rd phase. The first phase is 15 years from now, and then you get into the car, and the car says, hi, Israel, where do you want to go? You say to the office, the car says, you are too tired. You had a lecture today at HIT. I don't think you need to go to the office. Let's go to the beach. Okay, that's a joke, of course. But that's a good opening to start, and of course, I will dedicate the next 25 minutes or so to automatic or autonomous driving, and I will try to fly over the whole area. I mean, one can talk about autonomous driving for days, not hours, and what I'll try to do is to give you a snapshot, a glance into this area. We will cover basic technologies, we will cover human interface issues, we will also cover commercial issues, regulation and legal issues, a little bit ethics, and at the end, as promised to Ronn, we will try to look at the whole picture and say, and ask ourselves, what is required from somebody to be a dominant player in this industry, okay? But first of all, before starting to go deeply into autonomous driving, let me take a short ego trip and tell you who I am and what is my claim for fame to come here and tell you about autonomous driving. So my name is Israel Ronn. I'm the president and founder of Spotam, which is my own company. Comes after I was managing few companies. Last one was Cellocator from the Pointer Group, which dealt with what we call today Autotech. And Spotam actually is focusing mainly on automotive issue, on Autotech issue, high technology in automotive, that goes to the advanced automotive, connected car, safety equipment, data and cloud, and of course autonomous driving. Legacy telematics like Ituran or Pointer, fleet management, insurance telematics, and areas like this. Mobility and intelligent transportation systems that were described by Zev. And we give some attention to the Internet of Things as a whole and location-based services. Services that we give include business development, market research, management consulting, strategic consulting, training and seminars. I'm lecturing to you right now, and product initiation as well. And to those who are interested, give a look to Spotam.com, which is our website, and this is a professional website for professionals which hold professional information that might be interesting and important to those who are really dealing with Autotech. So now, let's start looking at autonomous driving, and I'll start, you see here, you see few logos, and that's actually a sample of so many trials, projects, and experimental tests that are being done right now these days in the world of autonomous driving. You have Uber, who is doing their own projects. Google has a Firefly project. They have the Early Rider project in Arizona. They do have a cooperation with Lyft. Volvo is running My Drive, level 4 autonomous driving that is running already for a year. We have Robotaxi in Japan, Dena, a Japanese company, together with Nissan, I'm sorry, running a project that actually using taxis to bring old people to whatever destination they want, and they want this to be operational for the Olympic Games in Japan. City Mobile 2, European Union project of public transportation and campus transportation. Gateway, a British project. Baidu, the Chinese, is doing the Apollo project, which is an open source a project to write a brain for an autonomous vehicle. Navia is a real operational autonomous bus running in Lyon in France, and that's just the beginning. I can mention the Sam product of Nissan, the Cedric of Volkswagen, and others. I mean, it's all over the place. I mean, we are not talking about something simple, something that somebody is working at the corner, but all the world is running after it, and that's probably going to be the future. But as you will see, there are some challenges ahead. So let's first of all talk a little bit about levels of autonomous driving. And what we have here is a version of the Society of Automotive Engineering. There is another version of the US government organization that is called NHTSA, National Highway Transport Safety Association, which is a little bit simpler, but I'll take this one because it makes it easy for me to interpret whatever is going on driving, which I will do later. So if you are thinking that what we have is simply non-automatic car and then a fully automatic car that you call as a car, it comes, it takes you, and later on it tells you that you are not going to the office but to the beach, okay, forget it. We're talking about various levels, starting from 0 and ending at 5. Level 0 is very simple, zero automation, like the cars that we used to drive. Then there is level 1, and level 1 actually says you have one automated function in the car. For instance, lane keeping control. I mean, the function that keeps the car within the lanes, or in the case that we know in Mobileye, warns us when we are violating the lanes and we are moving from one lane to another in an uncontrolled way. Level 2 says that we have at least 2 functions like this, but those are corresponding between them. They have some connection between them. Take into account something that exists in my car. You have lane keeping control, and you have adaptive cruise control that is capable to run in a specific speed, like a regular cruise control, but the radar keeps it in a safety distance from the car in front of you. So actually, you have a car that keeps the lane and keeps distance from the car in front of you. That's level 2 automation. Level 3, without making things too complicated, actually says that the car can be automatic, drive automatically in a specific segment or a specific scenario of driving. For instance, on a highway, before exiting and after taking on the highway, or in a traffic jam. Imagine a situation which already exists in some models of Nissan and GM for 2018 and even a little bit on 2017. You get into a traffic jam, you put the car in automatic mode, it does, you know, all the small moves, and you are reading a newspaper, okay? Although you are not allowed to according to the current regulations, but let's leave it aside. Level 4 begins to be interesting, and level 4 has importance to whatever is going on today in the industry. Level 4 says the following. Level 4 says the car can drive automatically in urban area, in highways, off-road, anywhere. Okay? Off-road is a different problem, but anywhere. But nobody can guarantee that it will always be able to handle any situation. So, at a point of time, we might face a situation that we are calling it re-engagement, which means the car says, I don't know what to do right now. Please, Mr. Driver, take the steering wheel and do whatever you think you need to do with the car. And then bring the control back to the car to proceed with automatic driving. This level creates a new problem, which is called re-engagement. How do we transfer the control? It's not that simple. I mean, if somebody is not, you know, synchronized with what's going on the road, and then immediately the car says, take control, it might be a problem, and there is a lot of work, including a very interesting IBM patent, of when and how do you detect such a situation and safely bring it back to the driver. And then we have level 5, fully autonomous. And fully autonomous, actually, you don't need no steering wheel, no brakes, nothing. The car will drive by itself. You might call it in, I mean, like science fiction. So this is about the levels of autonomous driving. And now let's give a look about the basic technologies. Some of them were described already by Zeev, so I'll try to run through it quite quickly. We do have the radar, the lidar, the ultrasonic, all the sensing mechanism. Lidar is laser-based, radar is radio frequency-based, and ultrasonic is like sonar based on voice returns. And all those technologies are aimed to allow the car to detect the environment around it. And we do have image processing. I mean, camera, 360 degrees cameras that, again, will be able to identify and detect all the objects around us and tell the car whether there is a pedestrian, whether there is a car, a truck, a tree, road, detect road signs that, by the way, only vision systems or V2I systems are capable to give us. And we do have high-definition maps, which are maps aimed at autonomous vehicles in order to allow them to maneuver in the areas that they are driving. I will talk about HD maps in a second. All those technologies are capable to identify objects and to figure out things based on artificial intelligence, mainly machine learning, which is the main runner today and when we are talking about artificial intelligence. We do have V2X communications, as they have described. We have location technologies, GPS, and some similar technologies that are allowing the car to detect its position in a very accurate way. We do have, by the way, an in-vehicle computing network and processors. I mean, today, somebody has an idea how many CPUs are in a car today? I'm talking about, let's say, 2016, 2017 model. Any idea? How much? How many? 100? Okay, 160. That's the third lecture I'm giving that somebody gave a good estimate. People are talking about 20, 30, 40, but we are talking about more than 100. Actually, today, a car is a computer network on wheels, and such a computer network on wheels needs to have a high-speed network, and it needs to be reliable and efficient. And then, of course, we have actuators. I mean, everything that will cause a car to make a steering, to make a brake, or whatever the car wants to do. HD mapping. I mean, one of the problems, and again, it was mentioned by Zeev in a different angle, of all those sensors, including V2X with their levels of reception, including vision, including lidars, is that no technology is ideal. For instance, vision has problems in night time, has problems in fog, has problems in bad weather, okay? RF might have radar, may have interference, and so on. So in order to back all those together, first of all, we invented the sensor fusion, something I'll show you in a second. But one of the main technologies that the industry, most of the industry, except Toyota, by the way, is counting on is that we will have a very, very, very accurate maps. And those maps need to be able to identify very small items, like an edge at the road, like a tree, like something in the size of a box, whatever there is there, fixed or temporary. And one of the main problems of those maps is to be updated on frequent basis. I mean, if I have a map that is updated to 2 days ago and somebody has put something on the road, an obstacle, map doesn't worth a thing. So the idea is to have cameras or lidars on a lot of cars, which actually will be and are beginning to be right now, and each car will be what we are calling a harvesting agent. It will, let's talk about image, it will all the time video whatever the car sees, transmit it to a map aggregator, something that collects the information from all the cars, and all the time updating the cars again, so the maps that they have will be as accurate as possible. Now, together with the vision, the lidar, everything around the car is relatively capable to understand the environment around it. So this is, in general, HD mapping, an interesting subject that, again, I can talk about it a little bit more, but let's leave it as it is right now. And I will not talk too much about machine learning, artificial intelligence, but the whole idea with artificial intelligence says that we are taking a lot of data and giving it in one of the cases, which is called supervised learning. We are telling the machine, okay, now there is a videotape, you see a person. Now there is a tape, you see a sign. Now there is a videotape, you see a cat, etc. The machine takes a lot of data, runs over it in special algorithms, and then later, on new set of data, it is capable to identify what's going on around it. So we have one step of data collection, and collecting data to train those machines is a business today with a lot of money. Then somebody needs to build the parameters that the machine will run on. There is a training stage, and once the system is stabilized and capable to identify various factors, then we can run new data. Most of the detection algorithms in cars are working based on this technology. And by the way, people who are dealing with it are dealing in an area called data science, which is beginning to be highly popular today at the high-tech industry. So we said that actually every technology has its own disadvantage, and we cannot get to 100% accuracy, and we are still dealing with a car. Now try to imagine, let's say that we are putting equipment and we are being mistaken in a detection in 1 to 10 million cases, okay? 1 to 10 million cases, it means that some car somewhere is doing a mistake probably every minute. And that raises a potential for accident, for casualties, fatalities, whatever you want. So we need to make sure that 1 to 10 million is not a number, and the solution of the industry is what is called sensor fusion. I mean, we have various sensors, we have HD maps, we take it all together and doing a second phase of machine learning, of artificial intelligence, in order to take all the inputs and all the probabilities, digest it together and say, okay, this is a person who is now crossing the road, okay? This is a cat, we need to be careful, but let's careful then when we are talking about a person. Okay, now an interesting example and an interesting problem. As you remember, I gave you a description of the 6 levels of autonomous driving, and I told you that we have level 4, remember? That's the level that actually runs automatically, but is not guaranteeing it. And level 5 is fully automated. And if we are looking at the current reality in the industry is stuck in level 4. My Drive project, Even Uber, and Uber even have some problems, and Google and others actually are keeping drivers on those cars, and the drivers are allowed and need to do what is called interventions. I mean, in some cases, they take control, okay, because the car doesn't know what to do. And that's the reason, by the way, that there was a huge backup in the predictions of the industry. I mean, if you were talking with somebody 2.5 years ago, everybody would have said that the 2025 will have fully autonomous vehicles everywhere. Now, everybody is talking about level 4, okay? And by the way, German legislation allows level 4 today, not for testing, but for real, okay? But with level 5, except Volkswagen that is talking about Cedric full autonomy at 2022, even Volvo that were pioneers with their MyDrive project moved it to the second half of the 2020s, okay? Now, one of the ways to overcome it is a very, very interesting cooperation between Nissan and NASA. Why NASA? NASA has what they call lunar vehicle. I mean, it's somebody that runs on the Mars or runs on the moon or whatever. And how does it work? It has artificial intelligence. It runs there because communication is not that fast, okay? So it needs to be independent. But there are points that this vehicle doesn't know what to do. So what it does, it stops and it sends information to an operator who sits on Earth, and he makes decision, plays with the sticks or whatever, I don't know, and then a decision is being made. So it has similarities with level 4 driving, okay? Now, when you have such similarities, there is basis for cooperation, and the whole idea is very simple. We will take level 4 cars, millions of them, let them run on the street, and every time that there will be a re-engagement event, we will log it, okay? Every time that the car will say, oops, I don't know what to do, Israel, Ronn, please take the steering wheel and do something, okay? It is logged, being put in the database. At a stage, training mechanism runs, okay? And we are improving with all the solutions that human gave. We are teaching the system again and again. The hope is that at a point, the algorithm will grow to become a level 5 autonomous driving. Okay, so after talking so much, let's very briefly, taking the Mobileye version, try to look at architecture of autonomous car. So we have 3 main layers. I mean, some programmers and some researchers are going to kill me, taking whatever they do lifetime and putting it in one slide. You know, that's how it looks, okay? But it's, of course, much more complicated. But the first level is a sensing level. It really diagnoses what happens around the car. What are the free spaces? What are the traveling path? What are the moving objects? We need to be careful from those moving, because if we'll hit them, probably it's a problem. And if we will ignore them, we might be in problem. And then there is the scene semantics. I see an object, now I need to understand that this is a road sign, and it says 50 miles an hour, okay? So don't drive here 70 miles an hour. Once the car, and all the time, the car is sensing and sending its object and environment detection, we have the HD mapping that adds to it, and now we're coming to what Mobileye calls the drive policy, the brain that takes it all, assessing threats, planning maneuvers, negotiating with other cars. That's V2V in the future, and it needs to be complementary. I agree with Zeev that you cannot trust it 100%, but it gives you the ability to understand the intention of the other car. Not only that it drives right now in Ben Yehuda Street, but that it plans to make a left turn into whatever, Yirmiyahu Street. And then, of course, make a decision and activate the actuators, make braking, steering, accelerating, or whatever. Okay, now, the industry, each company with its own version, is talking about a gradual move towards a full autonomy car. And you can see whatever is right now planned in various projects in various companies. We have highway pilot, single lane, Tesla autopilot, when they are not trying to crash into trucks. Automatic valet parking, if you have the service. Traffic jam, I told you we have products already. Highway autopilot, multi-lane, that's again Tesla, Super Cruise of General Motors and others. Public transportation with fixed route. You know what is the advantage in fixed route? Somebody has an idea? Easily mapped. You don't need to map with HD maps the whole world in order to cover the track of line number 5 in Tel Aviv. You need just to map the areas that the bus is going there. So it makes the whole story very, very much simpler, I would say. Urban driving, fully autonomous, and we have autonomous on shuttles, on taxis, on consumer car, on buses, each one with his own flavor, and there is a trial, at least one trial on each one of them. And something I will not touch today, but it's a subject for a lecture for itself, is an issue called platooning. What do we do with commercial trucks in means of automated driving? In one sense, Otto of Lior Ronn, by the way, the name of my son is Lior, and I'm Israel Ronn, so it's Lior Ronn, but unfortunately it's not my son Lior Ronn, who was purchased, I mean, his company Otto was purchased by Uber for $600 million, and there was a big trial because Google accused them in copying patents and intellectual property. But in addition to this, the whole idea is to organize trains of trucks that will drive very slowly while the first truck is leading the others. And this way you will save a lot of energy. You will ease the traffic jam potential in highways, and you will reduce the risk for accidents. And actually, there is already one product in tests, a cooperation between a company that deals with platooning, Peloton, and Omnitrack, an operator of fleet management at the United States. Barriers to adoption, guys. So regulation and laws. I mean, actually, somebody needs to go about every regulation, every traffic regulation, and understand what is the meaning of having automated cars on the road. Main issue, by the way, is liability issue. Somebody knows what I'm talking about when I'm talking about liability? I didn't hear. Okay, whom should we blame? I mean, if I'm sitting in a car, you know what? You know that there was an interesting case with the Firefly project in Mountain View, California, a year and something ago. A policeman stopped a car, okay? Go to the side. You were driving too slow, by the way, okay? Then he goes to the passenger and he says, license, please. The passenger, a lady who works at Google, said, I'm not the driver. I don't have a license, and the car drives itself. So now the policeman has a problem, okay? For sure, he became a famous man because he was interviewed by possibly every TV channel at the United States. But it reflects the issue of if there is an accident in such a case, who is responsible? The technology provider, the car manufacturer if he is not the autonomous technology provider, the person in the car, or whatever, okay? Service provider, you can imagine. We do have affected industries that might reject as a trend. I mean, insurance companies might lose part of their business or the market is changed. We will talk a little bit about car as a service that has a huge influence about parking lot, about gasoline stations. I mean, many industries, garages. You know what? Try to think about repair garages that are fixing cars, pachachut, what we say in Hebrew. Okay, what will happen to them if the level of accident is going to go down dramatically to 1/3 of what it was before? I mean, the business begins to be problematic a little bit. Cybersecurity, it was described by the lecturer before Zev. If somebody actually take a hold of an autonomous car, and now he does whatever he wants with it, so California State, by the way, today has a provision that says that the car needs to have means to allow external takeover in case the car goes nuts. And by the way, that might be good for heavy trucks, for terror acts as well. I mean, and this is something we have today. Technology pricing is an issue, and of course, the existing developing gap in infrastructure for V2X, for instance. Now, guys, a little bit of attention, okay? Try to imagine the following scenario, okay? A person is in an autonomous car and he drives towards a road pass, okay? Now, behind him, there is 3.5 tons truck, very close to him. So it doesn't have the brake distance in order to block. If he will stop immediately, he's dead, okay? Now, 10 small children get into the street, okay? Now the car has to make a decision. Who is going to die? Will the person in the car die? Or will the 10 children will die? And I can invent 75 scenarios like this of who should die and why should die, etc. We can sit down here all evening and talk about it. And that brings us to a situation that actually the first time, by the way, if somebody saw the film I, Robot with the rules of robotics, or read the Asimov book, which is stronger, I think, actually that's really the same thing, I would say. And today, programmers at lab needs to make a decision who is going to die in various cases. And actually, that's going to be solved by legislation. I don't believe that any company or any programmer on a real operational vehicle will take the responsibility about himself. And I must say one short thing. I mean, I was lecturing in a conference in Italy, and I was asked by an MIT guy, what is my opinion? What should be the main role when the software needs to make a decision between the loyalty to the driver and the loyalty to society? I said something like this. Look, if a company will declare that they are social and they take care of humanity, and their cars will do justice, and in case of a dilemma between the person who drives in the car and the welfare of the society, it will take the side of the society, what will happen is that everybody will praise this company and nobody will sit in their cars, okay? So we are seeing today a trend to say, okay, the car is supposed to be egoistic, okay? And at the end of the day, it will be legislation. Any other thing will not work. Okay, so one thing before my promise to you, with autonomous vehicles and with the growing capability of do autonomous car sharing and with better public transportation, we are expecting to see a change. There are a lot of arguments about it in the model of owning a car. I mean, today the idea is that everybody has a car. And the prediction towards the future is that if, just like this, I can push a button in my phone and a car comes and picks me up and I don't have parking problem because it throws me where I want to be. And I go to do whatever I want and the car goes to whatever the car wants. It's not my car, okay? Then people will start giving up the second car in a family, and then especially in dense urban area, they will give up cars at all. And this is the reason why we see Autotel in Tel Aviv, and we see Autolib in Paris, and we see a lot of Zipcar in the United States. We see a lot of car sharing projects where the prediction is a totally different world, with car owners only on rural area, guys which is their hobby, fun and sport. Street view is going to be without congestion, no parking blocks, because the parking difficulties are a reason for something like 30% of the vehicles hanging around in an urban area. And by the way, a research that was done by Strategic Analysts, it's a research company, a year ago says that the main motivation of people to favor autonomous vehicle is that they get rid from the problem of finding parking, which is quite hell. And there are going to be a lot of industries influenced. Okay, last, I promise to you. There is a very, very big debate in the world about who is going to control. I mean, as Mercedes-Benz CEO said, my competition is Google and Apple. By the way, I don't agree with him, okay? Unless he wants to be a Google and Apple, okay? But actually, in order to be a main player, I mean, you can always be a niche player, and Israel right now, which our auto tech industry is growing in a tremendous space, okay? But still, except Mobileye, which will become Intel's automotive headquarters, which is an opportunity to all of you after you will graduate, okay? But most of the companies here are niche players. They will supply this technology, LiDAR, vision, management system, whatever, okay? In order to be a main competitor, you need to have control on 5 areas. First of all, transportation as a service. We talked about the mechanisms that actually a car will be a service. And you see that every respectable car manufacturer has a mobility plan. Each one varies, but they have a mobility plan. The second is a virtual car, the brain, all the algorithms and all the machine learning and all the detection and everything. And then there is a car itself. I mean, you have a wonderful brain, but the world is not virtual. At the end of the day, you need to sit in something, and you need to have all those pieces of equipment around you that will give the brain the inputs to make decision. Now you have the need to have the capability to do mass production in quality level. Car is a quality level. You can't allow car to crash, okay, or to suffer from defects. And the car companies are well known in their quality traditions. And when you are dealing with all this system, then managing it with the right tools is an important aspect. Now, if you look at the Googles of the world, they are very, very strong in the virtual brain, okay? They have the tradition, they are much faster than the automotive industry, and this is why our dear friend from Mercedes-Benz said whatever he said, okay, because he's frustrated. They are doing things in a fraction of time when whatever they do. But if you are looking at the automotive industry, this is where they are strong, okay? And you can see what happens to Tesla with the Model 3 introduction and with the truck, the electrical truck introduction, because they are coming from the other side. So it's going to be a giant fight, and I don't agree that Mercedes and Google are the same, and we will see mergers and alliances, and we are beginning to see it already, a different lecture, and at the end of the day, those who will win will be those who will be able to create the right coalition, and it will be coalition because there is a lot of deep knowledge in each side and wins the game. This is, by the way, the reason that we had a $15.3 billion acquisition of Mobileye, but I can give you 700,000 other examples as well. So that's it, guys. Thank you very much.